Okay, the next thing we're going to look at in terms of volume is the specific case of a special type of prism, the cylinder. Now, a cylinder is still a prism because it meets that condition of the front face and the back face are identical and we have uniform height throughout the object, i.e. the height doesn't dip up or down, it just goes straight across. But a cylinder, we can expand this a little bit. It is still area times height, but we look at the area as just being pi r squared. Because you'll remember that the area of a circle is pi r squared, and that's what we're going to use in place of AH. So it is still volume is equal to area times height, but we're just replacing area with pi r squared. So, in example 2 here, we want to find the volume of this cylinder, and notice how it's asking us to give our answer to 3 significant figures. To find the volume of the cylinder, we'll say that volume is equal to pi r squared h. Now please remember that these formulas, these ones are not given in the exam. You need to remember what these formulas are. So volume is equal to area times height, and volume is equal to pi r squared h. So in order to do this, let's write down our variables. So we've got pi, we'll get r, and we'll get h. So we know what pi is. Pi is just the normal pi. The radius and the height, well, if the diameter of this cylinder here is 12, the radius has to be 6, because that's the distance from the centre out the way. That's the radius. And the height is 18. So let's put these values into the formula. So volume is equal to pi times 6 squared times 18. So go to your calculator, let's just go ahead and work that out. Pi multiplied by 6 squared times 18, and I'm using the pi button here. It gives the most accurate answer rather than using 3.14. And that's just going to give me 2035.75204. I want to round that to 3 significant figures, so it means that I'm going to chop my number off after the third figure, or I'm going to make my rounding decision, which is probably a bit more accurate. So because the 5 here is 5 or more, so we round up the way, that 3 becomes a 4. So all I'm going to say is that the volume is going to be 2040 cubic centimetres. And that's to 3 significant figures. So it's always important to give your unrounded answer first of all, and then follow that up with your rounded answer. Example 3 says a container in the shape of a cylinder with a diameter of 20 centimetres is to be part filled with water. If 6 litres of water are poured in, calculate the depth d of water in the cylinder. So let's read that again. If 6 litres of water are poured in, we have to calculate the depth of the water. Given that the diameter is 20 centimetres, so this is really a backwards volume question. So we know here that we really know the volume. If it says that it's been filled with 6 litres, the volume is 6 litres. So that means that the volume is 6,000 millilitres. And what you'll remember from first year, when we speak about liquid volumes, 1 millilitre is equal to 1 cubic centimetre. So our volume is 6,000 cubic centimetres. So the volume is 6,000. We know what the diameter is at the bottom, it's 20. From that we can get the radius. The radius is 10. Now we know the formula we're going to use is volume is equal to pi r squared h. This question is asking us to find the depth of the water, i.e. find the height. So we know what the volume is, we know what V is, we know what R is. We can put this in and rearrange to find out what H is. So that's going to give me 6,000 is equal to pi times 10 squared times the height. In this case we're calling it D for depth. So we don't want the pi times 10 squared to be there, and since that's multiplying the D, we divide by it. So we say that D is equal to 6,000 divided by pi times 10 squared. And that's just what we plug into the calculator. So 6,000 divided by, and remember when you're typing this in, like I've said before, watch out for what you're typing in terms of the bottom. Type it into the calculator as 6,000 divided by, open bracket, pi times 10 squared, close bracket, so that you are dividing the entire denominator and not just the pi and then multiplying by 10 squared. So 6,000 divided by pi times 10 squared, close bracket. So that means that the depth D is going to be 19.1 centimetre. Okay, so part B here says if the full height of the cylinder is 45 centimetres, calculate how much more water is needed to be poured in to fill the cylinder completely. So for this, let's just go ahead and find the volume of the full cylinder then. So volume is equal to pi r squared h. So it's going to be pi times 10 squared times 45. So back to the calculator, pi times 10 squared times 45, which is going to give me 14,137.17 cubic centimetres. What we're now being asked to do is we want to work out how much more water is needed to be put in. Well, if 6,000 cubic centimetres is already in, to work out the difference, all we need to do is work out 14,137.17, take away 6,000. So that's going to give me 8,137.17 cubic centimetres. Now this is given in terms, the water is given in terms of litres, so we can either write it as litres or millilitres. I think you're fine to write it as millilitres here. So I would say that the volume still to be added is 8,137.17 millilitres. And that is finding the volume of a cylinder.